Hello everyone, welcome back. In my previous video, we learned about classes and objects. So in this video, let's extend the topic bit more and learn how we can handle class hierarchy or inheritance in Python. So in layman, if you would like to understand inheritance, it is a term which means pulling something from others or say inheriting from others. The same concept can be applied to Python also. Here inheritance means inheriting properties and methods from another class. So basically here we deal with parent-child relationship. So if you can see on the screen, the parent class, which is also known as the base class, is the one which is being inherited or the one which is giving the classes and the properties. Whereas another class which is child, or you can also call it as a derived class, is the one which inherits the properties which are given by the base. So let's understand it again. Here parent class would be the one who will give, whereas the child class would be the one who is going to take. So let's create a class and understand this concept in much more clear manner. I'm on my Jupyter notebook and here I am creating a class vehicle. So in this we will define some initial things. So the very first thing, like we discussed in last video also, we need to have a init function, and here I am saying that every vehicle will have color as well as the make. So I'm taking two variables here, color and the make. So here what we are trying to do is self dot color. Let me keep it in small case, and here I am assigning the value which is coming from the color. So this is my one class which is vehicle. Let's define another class called car. So vehicle can be anything, truck, car. So I'm going with a class name car. And what this car class will do is it will inherit all the properties from the vehicle, because car itself is a vehicle. So it means whatever the properties vehicle is having will also belong to car. So rather than rewriting the color and the make again, what we are trying to do is we will simply inherit the vehicle class here in this way. So we need to put parentheses, and inside that we need to pass the class name. So this line is performing the inheritance for us, and it is saying that whatever is defined inside the vehicle class, just pull it for me, so that instead of rewriting again and again, I will just reuse that whatever is already in plate. And here let's keep it simple by writing the pass. So pass is the keyword we use whenever we do not want to add any members of the class. So as of now, let's keep it simple. I'm not going to add any properties to my car class. Rather, I want to show that how we can utilize the properties of the vehicle class when we are creating an object of a car class. So I'm going to create an object of a car class, which is car. And here I need to provide two things. First is the color. Let's say car is red. And here I can say make as BMW. Now if I will go ahead and say print car dot color. So you will see that red is coming. Although this car is not having any property named color, still we are able to use it, and that is possible just because of the inheritance. So we are inheriting a vehicle class which is having a color and the make property, and that's the reason we are able to fetch everything just with the object of the child class. So here vehicle is your base class, or you can say parent class, and car is the derived class, or you can say child class. Any terminology you can use it for your understanding. Now let's add the init function to our child class and see what happens. So let me copy this entire thing so that you will not get confused. So this is my vehicle class, this is my car class, and here I am planning to, instead of pass, now this time I am going to define my own init here. So init is my function and it will take three parameters: vcolor, self, vcolor, and the make. So let me define it again, or I can quickly grab it from here. Okay, and so what this particular line will do is it will create an init function of this class. Now in this case, if I will try to access car.color, it's not going to work. Let me quickly show you here. So I will make pass here, and let's create an object of car class again this time, and pass this values. Now if I will try to print car.color, you will see that we end up getting the error that there is no attribute named color which is associated with car. And this is happening because we have defined a new init function in our child class. So if you are doing it in such fashion, we are restricting ourselves not to utilize whatever is defined in your base class. Right? So how can we solve this problem? We want to define init, but at the same time we want to inherit whatever is in our parent class also. So in order to achieve that, we need to make a simple change here. What we can do here is, instead of pass, we can use class name, which is the parent class name. And here we need to call the init, which belongs to parent class, self, and here just mention color and we make. And now if I'm doing here as this line, sorry. Now if I'm doing it here, because now we have defined local init, we have pulled in the init which is in our base class, and if we are trying to read the property, now we are able to do it. So this is how you need to define and handle your init functions whenever you are going with parent-child relationship. There is another way to handle the same situation, but in that situation, let me grab this and I will quickly show you the chain. So rather than calling the vehicle itself, you can use an inbuilt function which is super. So super will do the same thing for you. Let me it takes 3 parameters, but only 4 were given. Now what is happening here is we are doing super, so it means you need not to define the self again here. If I will execute it now, it will show me the result. So whenever you are going with the parent class name here, then in that case you need to define all the parameters which are in your parent. But when you are using super, you will just take the parameters which belong to your class rather than using the self. So this is another way of handling the parent-child relationship. Now let's proceed with another example. This time what we are going to do is we will try to add more properties. In parent we have few. Let's try to add some properties which are only related to the child class. So let's say name. So car can have a name. I cannot say that vehicle's name. We have to define, or we have to come to very ground level that what this type is. So for me, I have a specific property which is like car name that is not part of the vehicle class. So let's see how we can define it here. So I will quickly go ahead and add car name. And here I can say self dot name equal car name. Now if I will go ahead and create an object of my car class, I need to define these three parameters. So earlier there were two, now I have introduced an additional property and I want to initialize it here itself. So here I need to mention, so red is my color, make is, I can say, BMW again, and name I can say X1. If I will go ahead and print any of these, let's say X dot name and X dot color. Oops, so X is not defined, not X, it should be car here, my bad. We need to use the same variable which we have created to reference this. So if I will do this, oops, okay, it has to be in small. Okay, so now you can see that, sorry for all these typo and uppercase, but the idea behind this particular thing is we can access the base class properties as well as we can add our new properties which will belong only to us. So it means only to the car class, and this is the property which I have recently added, name, which is part of only my child class and not of parent class. Similarly, this is the property color which is coming or flowing from my parent class. So these are the various scenarios you can handle, and hope I try to cover most of these. So do let me in comments if you feel that any of the scenarios I haven't covered here, and we'll cover those up. Thank you.